Okay, so in this video, we want to look at two more examples of quotients involving a composite function. Here we have the example f of x equals 20 over the quantity x squared plus 9x plus 12 raised to the third power. Now, this is one situation where we can actually avoid using a quotient. Actually, we can always avoid using a quotient if we use this approach and do everything with the product rule. If you're comfortable with that, great. But here it really is beneficial. So if I do it right now, I have 20 over that stuff. So I would have to use the quotient rule. But I can realize that that stuff in the bottom is the same as that stuff to the negative third. And the 20 there is a constant. So now I have a product where the 20 is a constant, and I don't have to use the product rule for that. Now, if that was 20x, I could do it with the product rule, but you might just prefer to go ahead and deal with the quotient rule in that situation. That's really up to you, and it's really a preference. Some people don't mind dealing with those negative exponents in the product rule, and they just use it all the time, and you don't worry about the quotient rule at all. Hey, if you're that kind of person, go for it. But here it's definitely beneficial to write it as a product because it's multiplied by the constant 20. And we can completely avoid the quotient rule, and we just have to use the chain rule. So we realize we have a composite function there. The inside function is x squared plus 9x plus 12. When we replace that inside stuff with u, we would get 20u to the minus third power. And then we just go ahead and we invoke our chain rule. It says the derivative will then be the derivative of the outside function. So 20u to the minus third, we multiply by the minus third, get negative 60, u to the negative fourth, and then times the derivative of the inside function, which would be 2x plus 9. And then to finish it off, we convert u over to the polynomial there, x squared plus 9x plus 12, and we put it in the right place. It's a negative exponent, so the negative fourth is going to go to the bottom and be that stuff to the fourth power. And we can just leave that as negative 60 times 2x plus 9 over x squared plus 9x plus 12 to the fourth power. Now, if I was going to turn around now and do a second derivative here, then I'd probably go ahead and multiply through by the 60 in that numerator. But here I don't need to. There's no need to. It doesn't make it any better writing it out. So that's up to you there. You can multiply through or not. But if I was going to do the derivative, I would probably go ahead and multiply because it would make the top a little bit simpler looking. Moving on, one last example here. Consider the function here, y equals sine x over sine x plus 1 to the third. Sine x over sine x plus 1 to the third. There's really two ways to do this problem, at least two. The way we're going to do it is realize that this is a composite function where u is that fraction inside, sine x over sine x plus 1. And then f is u to the third. That's how I'm going to approach it. You could also distribute that third power through, get sine cubed x over quantity sine x plus 1 to the third. And then you could work it out with the quotient rule using the chain rule twice, if you're comfortable enough to do that. Here we are going to still need to use the chain rule, but I'm only going to need to use it once because I only have the u to the third, the outer function, and then the inner function. Now to do the derivative of the inner function, I will need to use the quotient rule. So we begin with our chain rule. First and foremost, y prime would be the derivative of the outer function, 3u squared, then times the derivative of the inner function. Now the inner function, I need to use the quotient rule. So that's going to be the bottom there, sine x plus 1 times the derivative of the top, the derivative of sine, which is cosine x, minus the top, sine x, times the derivative of the bottom, which would be cosine x. And then that's all going to be divided by the bottom function squared, sine x plus 1 quantity squared. All right. Now, let me simplify the stuff on the numerator here. So I'm going to kind of write that down there. If I multiply through sine x plus 1 times cosine x, I'm going to get sine x cosine x, all right, sine times cosine, plus cosine times 1, which would be cosine x. And then that's minus sine x cosine x. So notice that the cosine x's here, just sine x cosine x's in that top just go away. And the whole numerator here is just going to be cosine x over sine x plus 1 squared. So that's simplifying that piece on the inside here. And then we just have to deal with this 3u squared stuff. What's u? U is sine x over sine x plus 1. So we can write that down. 3u squared, which would be sine x over sine x plus 1. All right, and then times, after we've simplified this fraction, it's just cosine x over sine x plus 1 squared. And now we have just a little bit further to go with this to kind of clean it up and simplify it a little bit more. And here we can distribute the square through. That'll give us sine squared. Group the 3 with that. That'll be 3 sine squared x cosine x on the top. And then on the bottom here, I'm going to have a sine x plus 1 squared with another sine x plus 1 squared. So I'm actually going to have a sine x plus 1 to the 4th power there in the bottom. And so we get 3 sine squared x cosine x in the top over sine x plus 1 to the 4th power in the bottom here. And so hopefully these examples will kind of help you get started with the chain rule and the product and quotient rule. And these are probably some of the harder problems you're going to encounter. So please take your time, be careful, and try not to get too frustrated, as it is really easy to get frustrated. Make sure you understand the ideas. If you're understanding those and then making little mistakes here and there, well, that's going to happen. Just try to be careful and always improve. Till next time.